Welcome, on behalf of Olin's Robotics Lab, to the demonstration of PhoenixBot, Olin College's agricultural robot named for its focus on regenerative agriculture and Olin's mascot, the phoenix. In today's society, global food systems face a critical juncture. We must significantly increase global food production to keep pace with the growing population, while simultaneously mitigating the harmful environmental effects caused by current mainstream, unsustainable farming practices. The Olin Agricultural Robotics Research Team traveled to several small local farms to explore what challenges farmers face in food production.
Weeding takes up, 50, 75% of the work we do. Some parts of the year is just weeding. Particularly organic farmers are trying to come up with different ways of combating the weeds.
I think a successful system would allow us to keep on top of some of these weeds while they're smaller, and that would allow us to get to the weeds before they reach the point where we have to hand weed or invest even more time in getting rid of them.
Most existing robotic weed control systems rely on either precise herbicide spraying, which involves the use of harmful chemicals, or on significant tillage, which negatively affects soil health. The PhoenixBot is intended to execute sustainable weed management practices while simultaneously maintaining or enhancing crop yields. Developing the PhoenixBot was divided into smaller tasks delegated to teams of student researchers. The subteams focused on the development of mechanical weeding, plant identification, field navigation, and system integration.
Once out on the farm, PhoenixBot displayed remarkable progress in its autonomous crop row following. Though still in development, the system was able to navigate the row autonomously for brief periods of time. Human intervention was needed when the algorithm failed. As it drove along each row, the system showed off its ability to accurately identify and locate intruding weeds. The onboard depth camera located a weed in three-dimensional space and passed that information onto the PhoenixBot mechanical weeder. The developing mechanical weeder system navigated to the identified weed and plucked it out of the soil with minimal disruption to the soil and crops. As it navigated and worked autonomously, PhoenixBot presented a safety-oriented obstacle detection system and avoided collisions with people or objects that got too close to it while alerting them with flashing lights and a loud buzzer attached to the front of the robot. To quantify the performance of the PhoenixBot system, 5 metrics were chosen. On-site testing revealed the PhoenixBot segmentation algorithm had a precision of 0.69, a recall of 0.7, and an IOU of 0.68, each on a 0 to 1 scale. A confusion matrix constructed from labeled on-site testing data for lettuce and weeds showed the PhoenixBot plant identification pipeline achieved a precision of 0.91, a recall of 0.85, and an accuracy of 0.88, each on a 0 to 1 scale. During in-lab testing, the PhoenixBot localization algorithm achieved a mean positioning error of less than 11 millimeters in the X, Y, and Z directions. Using video data during on-site testing, 904 out of 924 frames, or 97.8% of the frames, identified all 3 crop rows for use in navigating, and with the exception of 11 outliers, nearly 99% of our headings visually match what seems to be the center of the crop row. When commanded during in-lab testing, the PhoenixBot mechanical weeder system moved to weeds with a mean positioning error of less than 17 millimeters in the X, Y, and Z directions.
What the student team has developed here is truly exciting and amazing to see. They've taken a complex, multifaceted problem of autonomous weeding, including navigation, getting the robot to navigate on the farm, and the complex part of manipulating individual crops on the farm and building the entire system from the ground up.
I was really impressed by sort of the way that the students developed how it was driving and how it was identifying weeds that didn't really require any external inputs. It was just able to hop into a bed that maybe wasn't perfectly made, wasn't super long and GPS tracked, and just make it work. And so I think that that's really versatile and really great for use on small farms like this one.
Farmers, essentially, we're using the same tools, machines that we've been using for the last 50 to 100 years. So there is definitely some room for some modernization of the agricultural world. But I think it will take people like Olin students to come up with some of those advances.